Hi everyone. Here's a polytropic example. So far we have studied the isothermal and the adiabatic processes so far in class. I think it's important to also look at polytropic. So here goes a relatively simple problem. In this case we have an unknown gas at 150 kPa, volume of 0.3 meters cubed. Undergoes the polytropic process with N equal 1.3. The final volume of the gas is 0.2 meters cubed. Calculate the work done during this compression process. Right? So what does compression look like? Think about it. Okay, compression should be going from a larger volume to a smaller volume with elevation and pressure, right? So let's draw it, making sure that we can visualize the process. It's over here, 1 to 2, with a P versus V, and that V we'd like to put a line through. Now let's try to tackle this problem. We've been given the first pressure and volume, we've given the last volume, but we don't know the pressure at 2. So that's what we're going to look for, obviously, to calculate work, since pressure is needed to calculate boundary work. Walking through this, the plan would be to get the necessary pressures and volumes, and then move to a work equation calculation to calculate the work. So let's do it. Okay, this is a good point. In this case, R is not known for the gas. Once again, though, we don't need that. R was not part of our plan. So the key idea here is that in polytropic processes, you don't need to know R, nor does it have to be an ideal gas. State 1, like we said, is given. State 2 is only partially given. How are we going to calculate the unknown pressure? Well, we're going to use the definition of polytropic processes. For a polytropic process, a constant is equal to P1, V1 raised to the n, which is also equal to P2, V2 raised to the n. Since we know P1 and V1, as well as V2, we can solve for the unknown P2. Here it is. And that's the pressure. Now that we have the pressure, we have to ask yourself, how do we calculate work? Well, in the textbook, this is an equation you should memorize. Work in a polytropic process with N not equal to 1, that's a key point. We can calculate work 1, 2 equals P2, V2 minus P1, V1. The key idea is get the units right. So let's do it. This is the equation again. Remember, this is a capital W, not a small w. Plugging and chugging, putting in the appropriate values, you calculate 19.3, and it's a minus, right, because it's work on a gas. You're compressing the gas. But in this original key, they had kilojoules per kilogram, and they were mistaken, because if you look through the units, the denominator is unitless. The top has kilonewton per meter squared, which is kilopascal times meter cubed. The meter squared would cancel. You'd be left with 1 meter up here, so you'd kilonewton meter, and that's a kilojoule. So I hope when you reflect on this problem that the overall problem statement makes sense, the visual of what we're trying to attack makes sense, the physical aspect of compressing a gas is a clear visual for you, and then finally you work through the plan or execute the plan. Know the states. Work with the definition of polytropic processes. Know the equation for work. Work through the necessary unknown variable, in this case P2. And finally, plug and chug with unit vigilance. I hope that's useful. And we'll definitely cover this more as we go forward. Thank you.